Oh no.
So I'll continue.
George.
Hello, everybody. My name is Mario Loria. Welcome to the Orchestructure virtual event this May 27th. We have a really special presentation for you. It is going to be quite exciting. I think you're going to really enjoy our speaker today, Rajesh Jain, talking about Open Policy Agent. Rajesh is a cloud engineer at Palo Alto Networks, and he actually recently reached out to me. And we got talking, and I figured this topic was great. There's been a lot going around with OPA, including the recent Kubernetes podcast, which talked to some of the creators, as well as a TGIK special from the Heptio guys working through OPA. So it's been picking up a lot of steam, and I think it's going to be quite big as security and policy becomes a bigger problem for larger companies and small alike. So as always, we will be using the Orchestructure #Orchestructure channel in the Mainnet2 Slack network for live chat. Please post questions, comments, concerns. You can troll a little bit too if you'd like. We all like to have a good time in there. The video recording will be available on YouTube after the stream is done. We will also try to get the slides sent out and uploaded to our GitHub, so you can review those later on. I think Rajesh even has a demo plan, so this should be a really fun session. I'm not going to say much about him. I'm going to let him do most of the intro on what they're working on and himself. And without further ado, Rajesh, take it away.
All right. Thank you, Mario, and thank you, everyone. Good evening, everyone who's dialing in from Michigan. And I believe there might be people dialing in from all over the place. I saw a lot of accepts on the Meetup. So my name is, again, Rajesh Jain. I am a cloud engineer at Palo Alto Networks. And with me, I have Scott, who is a technical sales manager. We, again, tag team together in the Michigan territory. So let me share my screens here as we go through this session. So what we're going to talk today about is Open Policy Agent. And as Mario was setting it up, this is something we are seeing a lot in the market. How do you secure Kubernetes and how do you secure APIs? There's a whole lot of talk about securing your cloud native workloads. So we thought that's a good topic. We reached out to Mario and here we are. So what my presentation for today is going to be around OPA, and I'm going to do a session, a few demos as well. Let me just go ahead and slide. Okay. So again, a little bit about Prisma Cloud. We are part of the Prisma Cloud Speedboat at Palo Alto Networks, both me and Scott. The Prisma Cloud Speedboat is basically a very focused cloud native security platform, which is what we are building here. The idea is how do you actually make your container workloads or your serverless or IaaS or PaaS workloads secure, and all the way from building your workloads to shipping them and running them on the platform. So we are thinking about the complete life cycle and putting together all our muscle to build that kind of a security platform. And I'm sure most of you are familiar with Palo Alto Networks. Is a global leader in cybersecurity. 70,000 plus customers have been around for quite a while. And again, pretty big in the security space. Scott, you want to add anything here?
Yeah, just other than it's been quite an evolution. Kind of how I talk to some the folks out there is we're not your parents' Palo Alto Networks anymore. Everyone kind of associates us with the next gen firewall space, which is a market we created in big beefy hardware, either in the data center or at remote sites. And we've made a very big push from a cloud perspective. And with that comes a different set of personas that we're speaking to. So we're happy to be in front of the DevOps community and fostering those relationships and help bring awareness to the challenges that are out there.
Great. All right. So as a thank you thing from Palo Alto and from Prisma, we are doing a giveaway, a Prisma Cloud Backpack. I think Scott has got the email address here. So if you guys are interested, send in the email from your personal email or wherever you want to on this particular email address, and this third party will send you a redemption code. There's nothing that we will actually be handling this. There's something completely outside the Palo Alto. We don't own the store or your user information. All right. So with that, let me just move on to the agenda. So what we're going to talk today is Open Policy Agent. What is OPA? And kind of dive deeper into the policy language, Rego. We're going to talk a little bit more about how do you protect and secure your workloads, and specifically Kubernetes workloads. Going to look at some interesting use cases. And then we're going to talk about the CNCF community and what's the community doing. This is an open source project, so there's a fairly large community around it. So we can talk a little bit, how do you get help, whom to reach out to, and those kind of stuff. So this is the agenda for today. In between, we'll be doing demos. So I'll be actually doing a demo, or at least walking through the Rego playground. How do you build policies, and also how I'll be walking through a Kubernetes use case. How do you actually secure workloads in Kubernetes? So here's the funny thing. This is a tweet from Kelsey. As we were actually putting together this presentation and to this meetup, I think Mario tweeted out saying, "Hey, this is something that we are putting up." Kelsey actually tweeted that this is a super dope project, and this is something that it's really fun to actually see how you can write security policies in as executable code. And I think as a response, I think Mario kind of tweeted this thing, "Hey, we are actually working on this meetup." So this kind of, as you see, this is something that everyone is talking about, including Kelsey and including everyone out in the community. In fact, in the CNCF or in the KubeCon conference last year, there were almost a mini summit on Open OPA. And there was around 20 different talk tracks on OPA. So it's a fairly popular project now. It's taking off. So what is OPA? OPA is open. It's a general purpose open source policy engine. The whole idea is it's a general purpose because it can be used with variety of services, right? So you might have different kinds of services, whether it could be API services or service meshes or API gateways or Kubernetes or even host. And the whole idea of OPA is to be a general purpose policy engine. And few goals that OPA has or OPA has is how do you unify the policy enforcement across the complete stack, because nowhere you are just running one particular kind of workload. You actually might be having a variety of different workloads, and how do you unify the policy enforcement? And we're going to dig deeper into what are the challenges that people see when they think about policy enforcement. The beauty about OPA is OPA decouples policy decision making from policy enforcement, so it focuses more on the decision making and it leaves the enforcement to the service. So we're going to talk a little bit about the couple of these goals. So what's the current status of the OPA project of the enterprise landscape? What we have seen is where we are today is you have a variety of systems. You have different kinds of authentication systems, whether it's RBAC systems or ABAC systems, or you might actually have homegrown ways to handle policy, maybe in your code, maybe in your API gateways. And then the challenges that come along with those variety of systems is you don't have a single view of what kind of policies are placed. What happens if new rules are introduced, and if you want to make changes, what all changes? Let's say if I want to make a change in a system which might have a database and which might have API gateway and which might have some web server. So I need to make changes in all the three different places, and maybe these changes might be just temporary, or maybe then it might be a time of the day based. And then how do you actually use all these the fact that what is secure and what is not secure and who can access it? Like, how do you satisfy this audit and compliance requirements? Because you might have so many systems, so you don't have one single view of that. And then beyond that, you might have different kinds of workloads. You might be having, different kinds of policy requirements of VMs, for different kind of policy requirements for Kubernetes and Docker and databases and Kafka and service meshes and so on and so forth. So there is a whole host of challenges that goes along, enforcing those policies or building this a policy framework. And within Kubernetes, what we have seen, I mean, that one of the bigger use cases that we have seen is Kubernetes itself has got some pod-based security controls through RBAC, but they're not fine-grained to say, hey, I can actually, what kind of CPU utilizations I can do, or my pod can do, or how can I create a namespace, or can I actually push a image from a particular secure image registry. So those things are not necessarily satisfied by the current Kubernetes controls. That's where this is a new thinking of how do you solve those problems, and that's where OPA came in place. All right, so please scroll to the next one. So let's talk about unified policy enforcement. OPA is again, as we saw earlier, it's a general purpose policy agent. So it's not for a specific stack. It's not for your microservices or your API frameworks or your or for just for Kubernetes. You can actually use OPA for policy decision making in any of these different services. Maybe you might want to restrict who can publish on a Kafka queue, or who can write into a database, or who can read from from a query, or who can actually make changes to your cluster. So those are all different use cases, but all of them distill to one single problem: is like, what's the policy around it, and is there a decision, like who can do it, and can we enforce that? So OPA can be used across all these different stacks that are typically there. We have also seen areas where people are using OPA in infrastructure as code, whether it's Chef, Puppet, Terraform. So you can actually start thinking about using OPA there before you make changes to your infrastructure. The other thing that we talked about as a goal is a general purpose agent. So it's got integrations across the board with variety of different services. So as we looked at earlier, you can actually integrate with Kubernetes admission controllers, or you can do it integrate with Kafka or with Envoy, Istio, and I've seen interesting ones. We probably will going to talk about IP tables and maybe even databases or Elasticsearch. So there's and Cloudflare is pretty interesting. Cloudflare and Fastly, what they're doing in terms of on the edge. So you can actually take the same approach and then stretch it across the complete ecosystem. So let's talk a little bit about, jump a little bit deeper into what is the whole idea about policy decision making, and how does OPA decouple policy decision making from policy enforcement. So the way OPA looks at policy decision making is it looks at any service, a service sends in the request or a query, and the query could be any JSON object. And the example could be, can this user access a resource, or can the user make changes to this resource, or can I deploy this particular workload in this cluster? So all these are decisions which actually someone has to make, and then someone needs to authorize. And those decisions, when they are that query is sent in a JSON format to OPA, what OPA does is it actually has a policy document. So it looks at the policy document and looks at the query, and it has got some data that you can actually bind it with the policy document and make a decision. So all OPA does, or the OPA agent does, is makes a decision. Once it makes a decision, it sends that decision back in form of a JSON value object back to the service. Now the enforcement piece is left to the service. So service is responsible for enforcing that decision, not OPA. OPA is just responsible for making that decision, like what is it allowed or not allowed, or it's just not a Boolean decision, but it could be also a, 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 a document, like, hey, this is something that a set of values that we are going to provide you, what all things that Alice can do, or what all things can Bob can do. So this is something that you can actually use that output to enforce the decision. All right. So how can OPA be deployed? So there are various form factors in which OPA can be deployed. The OPA policy agent, and again, it's written in Go. So you can take the Go module, the Go library, and basically link up with your application, and that could be one way to deploy it. Other way, it could be actually running in next to your pod. So it could be a sidecar running to a pod, and you can delegate uh, the policy decision making to the OPA sidecar. And this is something that again, I'll probably bring this up again. We use that this kind of model when we do deploy with Envoy. And then you might actually be having a OPA service which can be hosted, which can be making policy decision making for a variety of different applications at a layer 7, or it could be application services like, can this application service talk to another application service, or can this application service talk to a database? Those kind of decisions, again, those can be centralized, and OPA can make those decisions for different kinds of application services. And then there are other ways of actually deploying it. You can deploy it as a host level daemon, as a system D process. So there are various ways you can deploy it. The whole idea is, what OPA is again, is a very lightweight process. So once you deploy it, it actually has it doesn't necessarily have any external dependency. So it actually has all the information it needs for the policy decision making. All the policies and the data it needs can be cached locally on the host, which means that latency is pretty low. You can also extend OPA to go out and talk or fetch data from some external service, or you can also extend OPA to basically discover changes in the policy, if there are any new changes that happens, right? So here's the way OPA, the agent actually interacts. There are different kinds of APIs that OPA provides. So one thing that I was talking about earlier is the bundle service API. It lets you download new policies, data bundles. If there are any changes in the policies, it can download them and cache them. It can also have a dynamic behavior, so you can actually have a discovery service. So anytime you change or make changes, some example that was given earlier was like, let's say you're discovering various policies, and these policies could be geographic based, right? So different policies for US, different for Europe and Asia. And what you could do is, you can actually download the bundle, and then when OPA, through the discovery service, and OPA deploys those policies, then it can, based on the geographical location, it can actually create different versions of of those policies. And then beyond the discovery service and the bundle service, you have the status APIs and the log APIs. It's the thing that I liked about working with OPA is it's got a VS Code plugin, and there are a couple of other developer-friendly tools that I'm going to show you today, which help you actually work with your policy, the Rego documents, and be really productive before you start pushing it out into in your production clusters. All right, so let's talk a little bit about the Rego policy language. It's a high-level policy language, as a declarative language, is assertion-based. So the whole idea about assertion-based languages, though it is pretty rich in terms of the constructs it provides, like it's got variables, sets, composite variables, arrays, you name it, and you can probably write a fairly extensive policy document with it. It's got rules, and you can import different packages and create modules, and basically reuse components. But at the base level, what it does is, for example, in this example here, is I can define the composite variable rectangle as width 2 and height 4. And then when you actually create assertion, is this rectangle, does it equal to have this, and then it'll just return a true or false. So that's the whole idea. Another example would be like, let's say that I have a policy document, a Rego document, which says that default allow is false, but if the user is Bob and the method is get, then allow, and if the user is Alice, then allow, no matter what the method is. So if the input document that the service provides to OPA is, hey, user is Bob and the method is post, it'll the decision that the OPA the engine will make is false, and then based on that decision, again the service will do the enforcement. Here's another example. And again, I just want to highlight this, like, since it's a declarative language, the way the assertions are made is basically, as soon as the first rule is matched, we kind of produce the assertion. So here's an example. Allow if the user is super user, else if there could be else statement like deny if it is admin and the source network is external. But if the input document says that the source network is external, user is super user, the path is admin Excel shell, it still allows because the first rule is matched. Input dot user is super user, which is what the input document said. It matches, and then it allows it. Though it actually, if it had gone to the second part of the else statement, it would have matched as false and would have denied. So you need to be very careful. The whole idea about bringing this example is OPA is again the Rego language. There is a learning curve, slight learning curve, and that's the reason you need tools where you can actually go out and play and make sure that you are writing the right policies. The way I learned Rego is a couple of ways. One is there's a Rego playground. So the guys who actually built OPA and the company behind it, Styra, they have created a nice project. It's called Rego Playground. So here's an example Rego Playground. So if you go to play.openpolicyagent.org, you have a bunch of examples. So I'll just pick a simple one. Let's say hello world. Let me just take this one. All right, so this is a simple hello world example. And if I have message, which is message is world, if I evaluate it, it shows up, like throws out the value of that particular variable. Now I can be a little more creative. Let's say I actually have an input document which has got the user as Alice, action as read, and the type as a dog. And then I have, as I said earlier, OPA actually takes the input document and the policy and the data that you can provide it. So the data could be organization data. For example, Alice is admin, Bob is employee, belongs to billing, and Eve is a customer. And then based on that, the different kinds of roles, what actions are allowed for a customer, what actions are allowed for employee, what actions are allowed for billing. So you can be creative in terms of how you want to organize your organization data or the data that supports your policy. And the policy would be that I would actually allow if the user is admin. So if I had Alice who was admin, and if I run this thing, it would actually assert as true. Now if I change it to Bob and I evaluate this thing, sorry, not selection. I can. That is a funny thing. So I actually had selected this thing. You can actually be creative. You can just debug this thing, and you can just evaluate the selection. So you don't need to evaluate the whole policy document. You can highlight it. This is what I had accidentally done, and you can just evaluate that particular selection. But in this case, if I want to evaluate the whole document, since it's Bob, allow is true because Bob is actually part of the billing, and billing is allowed to actually read a particular if the type is dog, it's allowed to read, right? Now if I add another animal which is not in this thing, so let's say pig, and then if I evaluate this thing, I have an assertion as false. So based on the input document, what's coming in, you can create these kind of policy statements, and then you can evaluate those policy statements. And there are a lot of things that you need to be like, for example, default is a keyword, is reserved keyword. Default allow is false. Then you can have various kinds of allow assertions. You can have functions over here, and then you can input is basically the input document, so you can actually parse the input document, and then you can call a specific function and create a subset of the document around it. So these are some of the examples that are there. A good playground for you to actually go out and look at how do you actually build a policy. So with the playground, you have all these different kinds of policy documents out there. For example, if it's a label existence, or image is safe and stuff like that, image is coming from a safe repo, right? And so on and so forth. So what I did is I also created some sample Rego documents. I have this in this particular GitHub repo, and which is what I'm going to use right now. So the first use case is we create a policy to check if the containers have label, and if there are no labels, then the policy denies those containers, and the message that I get is containers must provide labels for pod selector. There's another tool that comes that's very useful for developers. It's called conftest. Conftest lets you, it's basically written for testing OPA policies. And I have a link for that. How do you download? How do you download the tool? It's over. How do you download and configure the tool? So you could actually configure the tool. Once you configure the tool, then you can run the policy, and then you can actually see if I get. So let's take the example first one. So I'm going to take this one and I'm going to run it on my console. Hopefully everyone can see this resolution. All right. So conf test. So let me just cat the couple of things. One is the policy file and the input file. So the policy file is pretty simple. Like, it's a deny message if the kind is a deployment and it does not have a label, then the containers must have an app label. So if I run this thing, let me run this one. Right, so it tells me immediately that, hey, I need to actually, before I push this particular deployment file, I need to actually make sure that that I need to fix this one. So let's look at the deployment file. This is a JSON deployment file for the container. This is a Kubernetes deployment file, and if you look at the deployment file, I don't have for this particular spec. I have match labels. The selector match labels is null, right? So I can go back and fix this thing. So if I do my so the next one that I fixed it is got the match label. I have created a label and applied this label to my deployment. Now, if I run this particular file, it passes the test, right? So I can actually see that. All right, so this is basically my first test. The second test would be, I can actually go back and build another policy, which is containers must not run as root, right? So again, I'll run this particular policy. I'll show you what it would look like without how the policy file would look like, and how would the deployment file look like, and how do you fix that. So here's the So let me just run this one policy file. It says it's failed. If I look at policy, the Rego file, it says that if run as root is true, then our containers must not run as root. And if I look at the deployment file, if you look at run as user, the security context for that particular container, actually, I have not specified anything. So in fact, it's missing run as root. So that's the reason it's actually giving up this error. Now, if I fix this thing, and the way to fix it is basically you say run as user, as the user with a specific PID. And if I run this particular policy, it passes the test. So the whole idea is you actually develop this incrementally. You can create different kinds of policies in your pipelines, and then you match it against your again, you can create a whole bundle of these policies, and these policies then can be actually incrementally applied onto your deployment files. And the final one, and I'm probably going to skip this one for now, is how do I, or maybe I'll just walk you through that. I'll probably very quickly walk through that. This is basically images come from untrusted repo. So here's another example. So it says that the image MySQL comes from untrusted repo. So if I look at the file, the deployment file, it is actually my trusted repo is Holy, but my untrusted repo, MySQL comes from wherever. It could be from Docker Hub or whatever, which is untrusted, and I don't allow it. If I want to fix it, I want to actually make both of them come from Holy, and I can actually have this policy pass. So the whole idea about building these kind of policies and testing it out incrementally is you can actually make it as a part of your DevOps pipeline, build these snippets of policy before they become a part of your final deployment. And once you do that, then you can take these policies and then apply it as a bundle, and maybe compile them and then apply it as a bundle across your cluster. So let's go back to our presentation here. So this was a short presentation on the Rego playground. My suggestion would be this is a great tool. Feel free to actually experiment with your with your policies over here. So jumping on to Kubernetes, so this is a use case that I think most of you guys are familiar with, and many of you guys are trying to fix it through a variety of mechanisms. The way Kubernetes API server looks at any changes to its configuration is any request that comes in. Let's say a request could be that I need to deploy a new pod, or I need to create a new namespace. Any of these requests that are made to the APIs, the Kubernetes API server, goes through this particular pipeline. So the pipeline is you first need to authenticate and authorize. Is the user authenticated and authorized to make changes to the Kubernetes objects? Then it goes through something called as admission controllers. So there are two different types of admission controllers. There is mutating admission controllers and validating admission controllers. They are slightly different. Mutating ones actually can change the incoming request. So once you can change it, the changes could be like I can actually add new stuff, or I can make changes. Let's say I might want to add labels, or might want to add some kind of quotas or memory limits, or whatever it could be. So those could be mutations that you can apply on your request. And the validating would be something that is just yes or no, like all my pods are supposed to have labels, and if they don't, then the validation admission controller fails that particular request, and then either you're allowed to make changes or not allowed to make changes. So this pipeline is something that OPA uses. What OPA does is OPA actually extends this pipeline. The OPA policy engine sits as a part of the webhook. So, and the admission controllers delegate the policy decision making to OPA. OPA makes the decision and sends that decision back to the admission controllers, and the admission controllers are the ones that make the enforcement of the policy. So there's a new project, and I think this is something interesting that you guys probably, as you start experimenting with your Kubernetes clusters, you probably will start looking at this thing more closely. The OPA Gatekeeper project, what it does, it actually, the whole idea about how do you actually deploy OPA and how do you actually make it as a part of a Kubernetes cluster on your API, and then how do you actually have that integration, the webhook integration. It's kind of a little cumbersome if you are doing it on your own. The Gatekeeper makes it very simple. What it does, it creates custom resource definition. It extends the Kubernetes APIs, and it creates two CRDs. The two CRDs are called constraint CRDs and constraint template CRDs. The whole idea about is you extend the policy library. You create policies in the constraint libraries, and then you apply those constraints on your resources. And I think I probably might have some time to go through an example with that. And once you do that, the idea is the same. You are still using admission controllers, and you're still using OPA, and you're still using policies, but the way that the whole pipeline becomes, or the deployment scenario becomes pretty simple with Gatekeeper. Uh, the current functionality of, so here's an example of the constraint template. A constraint template might look something like, what is the constraint applied on, and then what is the policy around it. Right. So what we can do is, I can walk you through the admission controller demo, and there are two parts to the demo. One is the one that you would actually use, let's say if you have created your own admission controller and your webhook, and then how would you do it? And then the other would be through a Gatekeeper. So let me actually jump onto. So both me and Scott, we part of Palo Alto Networks. What you're seeing here is the product that we actually support. This is a product which actually lets you, again, as a part of the whole ecosystem, securing all the Kubernetes APIs and the Kubernetes resources. It also lets you create OPA policies, right? So again, this is just a nice UI on top of the same framework that we talked about. There is an admission controller that sits next to your in your cluster, and then there are policies. So example policies would be a privilege pod. If it's a privilege pod that's created, then you can actually either block a privilege pod from being created, like how you can create a policy which says that you don't let a privilege pod being created, or you can alert notify someone. Another example would be that I can actually have a pod with sensitive data on that, right? So you don't want to create pods with sensitive data. So these are different policies. Again, you typically will be creating a set of policies, a host or a bundle of policies, and deploying that in the cluster similar to this. And then you would be either enforcing the policies through your admission controller, saying, hey, block that particular pod. So I don't want to actually create privilege pods. Or I can say, I can say, uh, block a pod which writes secure data to or mounts a secure file system, right? So in this example, I have actually enabled two policies to be blocked. And then what you could do is, you could actually have a CI/CD pipeline which runs this whole pod creation. So there's a demo repo that I have. In the demo repo, I have different kinds of deployment files which are creating these different kinds of pods. Different kinds of pod would be, let's say I'm creating a privilege pod, right? So this is the privilege pod that I'm creating, and I'm running this particular demo pipeline through Jenkins, right? So let me run this thing. So if I build this pipeline, it actually we just kickstart this pipeline. All right, build now. Oops, it logged me out. All right, build now. All right, there you go. So what you will see is as I'm pushing these pods, and I can actually mark this build as failed. For example, this particular one, which was a privilege pod that got created, I can mark it as failed because my admission controller looked at the policy, evaluated the policy, looked at the basically the incoming request, and marked this as a failed task. So it wouldn't let me create pods on that particular cluster, privilege pods in the cluster. Same thing with sensitive file system. So again, if you can go back to your events, and I can actually look at admission events, I can see this particular event that I'm not allowed to create a pod with the sensitive file system, or I'm not allowed to create a privilege pod. So those are things that can be marked. Again, this product is is from Prisma, the product that me and Scott, we both support as a part of the overall security platform. And the whole idea is we can give you actually a nice way to manage your policies, all your admission controllers, and actually a DevOps pipeline on top of Kubernetes clusters that you might be running. So that was the admission controller a demo. Additionally, what you can also do, and I have that's a part of, let me actually just bring up the repo here. If you are doing this on your own, you could also be deploying a gatekeeper. So here are some instructions how do you deploy gatekeeper. The one that I showed you was without the gatekeeper, but if you want to deploy through a gatekeeper, you could be deploying gatekeeper, and then you could actually be creating constraints. So I'm not going to go through the demo of this thing, though I have it running. I just, for the sake of the time, just want to be cognizant of that. So you could actually create different constraints. So this is example constraint template, and which in this example, what we are looking at is this is the Rego code, which says that you must be providing labels. So anytime any new object that gets created, and the template doesn't know what it's applied on. So the template is basically a reusable template, a constraint template. And then you can create, so anytime you provide this particular create an object, then then we are going to actually enforce this policy. And what you could do is you could actually take this template and apply on a resource like a pod or a deployment or whatever it could be. So that's a reuse of the templates that you can do. So once you apply the template and then you apply the constraint, then you can actually, and I have already done that. So I can run this particular in my Kubernetes cluster. If I create this particular pod, since if I create this particular pod, it'll actually the constraint will be applied by the gatekeeper. So the gatekeeper calls OPA, and OPA gives a decision that you need to actually trying to create a pod, and the pod needs to have a label, and it'll actually come back with this particular error. Now I can actually change it, and I'll show you both of these. Uh, so in this case, if I look at this particular deployment file, this particular deployment file has the label busybox owner. That's the reason it actually the gatekeeper allowed the pod to be created. The earlier one did not have the label. That's the reason the pod was not created. Again, the idea here is it's fairly easy now with the gatekeeper to create validating admission controller and webhooks. Once you do that, you create a constraints and you can create a constraint templates, and then you can actually apply this across all your Kubernetes objects. The other thing that I want to cover is mutating admission controller. Mutating admission controller is not yet a part of the gatekeeper project. I'm assuming it's going to be, well, it's going to be a fun project. I think with that, it will take a lot of load from the DevSecOps or the security folks, because you might have, and from the developers. So you might have developers who will be pushing out code or the containers, and they probably might be missing out on new rules or new changes. And the mutating admission controllers can actually make changes through the deployment files. Let's say that I need to have labels, I need to have quotas, or I need to have whatever it could be, like some environment variables. Those all things can be injected automatically by the policy agent, and that can be done by the mutating admission controller. So that's something going to be, I believe, as a next step, that's going to be a really interesting use case for OPA and how it actually evolves from there. So here's an example. Again, this is a part of the repo that feel free to go through this. All these examples, these two examples I have taken from the Katakoda tutorial that was there, a part of OPA. I think it's on the openpolicyagent.org website. So you can actually play around with that, or you can go to this website and GitHub repo and clone it and play with that. All right, so those were the couple of use cases that we saw in the Kubernetes admission controller. You can create, to just sum it up, you can create your own admission controllers and your webhooks, and then you can play with that, or you can use Gatekeeper. The other interesting use case that I saw is how do you use OPA with layer 7 enforcement of policy. And this could be through Envoy or Istio service mesh. And again, a simple example here is you can actually deploy OPA as a sidecar. So you could actually have Envoy running as a sidecar, and then you can extend Envoy's service authorization filter to call OPA for in-service authorization through gRPC. So once you do that, anytime a new service authorization comes in at layer 7, let's say I want to access a database or whatever it could be, or I want to access microservice A to microservice B, those policy decisions Envoy can actually forward it to OPA. OPA can make a policy decision on behalf of Envoy, and Envoy can then actually enforce it. So it fits very nicely with OPA and Envoy. And again, there's a really nice blog post if you want to follow that on the OPA website or Open Policy Agent website. Another interesting use case that I've seen, I'm sure a lot of you guys will be very excited about, is compiling OPA policies. Though there's a very little latency, you can also compile these policies as WASM files and deploy it on the edge, right? You can actually put it on, on your CDNs, and then they can be executed on the edge. Which means that you can put it on traffic or API gateways, and they can start making decisions or policy decisions on behalf of you. And it's very small piece of code. Like if you look at the comparison, a single statement is just 30 kilobytes of WASM file, and 300,000 statements, just 20 megs of WASM statement on disk. And you can put it evaluates 20x faster than regular Rego code. So I'm going to keep an eye on this particular feature. I think it's evolving, but this is something that's going to be very useful for a lot of CDNs or a lot of policy decision making that happens in API gateways or on the edge. Right, so this is how you would actually build a Rego file into a WASM file and compile it and then deploy it as a part of The other interesting use case, as I said earlier, I mean, there are a lot of integrations out there. There's Kafka integration, there is Ceph integration, there's Terraform. There's someone, I think, some student doing this IP tables integration, where you can, have OPA rewrite IP table rules and make changes to IP tables. So this is pretty interesting. And again, the whole idea about decoupling policy enforcement from policy decision making lets you actually OPA make those policy decisions for you, and then you can have a variety of controllers. The controllers could be, in this example, IP tables controller. All right. So let me just quickly go through some of the examples here before I start taking questions. So again, this project has taken off in the last, I would say, 6 months. It's graduated from CNCF incubating, basically to sandbox to incubating, which means there's it's now almost a first-class project. And you will see a variety of people start adopting OPA. Styra is a company that's behind it, but there are a lot of other companies working on top of it. You have Netflix, actually, were the earliest adopters of OPA. How do you actually have fine-grained control, access on different kinds of microservices, which might be written in different languages, and you have a uniform framework to enforce policies. Then you have Pinterest using for Kafka. I've seen YouTube or KubeCon videos on TripAdvisor. They use where TripAdvisor uses for as a testing framework before they make changes on ISC code. Capital One actually does in policy checks in the CI/CD pipeline. So there are many more really interesting use cases. If you go to this particular website, early adopters, there's a variety of use cases. So you can actually start thinking about how you want to start. I mean, the easiest use case that I've seen and most of folks that I work with is the Kubernetes use case. But then they start taking that Kubernetes use case and start extending it to different things, maybe databases, maybe Kafka, or maybe it could be CI/CD pipeline. So you can start extending it beyond Kubernetes use case. The community is a couple of things that I want to point out here. Openpolicyagent.org, that's the name of the project. And most of the code that is there is in github.com. Open Policy Agent, Styra, as I said, is the biggest contributor. We talked about, there's a Slack channel or a Slack workspace that I've subscribed to. I would encourage, if you guys are interested, go ahead and join this one. And there's a Rego playground that I showed earlier. Yep, and this is the website I was talking about earlier. All right, the last slide that I want to talk about, is just a boot camp that we are going to do as Prisma Cloud. Again, OPA is becoming a bigger part of our Prisma Cloud security platform. We do container securities, serverless security, and the different kinds of security. But we also integrating OPA now as a part of our security platform. And we are doing a workshop. It's on June 18th, 11 a.m. to 1 p.m. to just learn specifically around Prisma Cloud. So if you guys are interested, Scott has his email address over there, and he's it's basically a hands-on workshop. The format is hands-on. So if you guys are interested, you can do that too. So with that, I will jump into Q&A. I think Mario told me there might be some Q&A questions coming on the Slack channel. One of the questions that I struggle with, and I think I would encourage everyone to start thinking about, where do I start with? Like, where should I start with? There's so many things. I mean, that you can start with. Whether should I go into Rego and learn everything about Rego, or OPA, or Kubernetes admission controllers, gatekeeper, and so on and so forth. I started with examples. I look at some of the examples that were there in the Rego playground, and I looked at the Katakoda, the playground, and then I actually used Gatekeeper for my particular use case, and then I had OPA in my product, so I could map it very easily to how we can actually use it in the admission control. So if you have any questions like how do I start, where do I start, what kind of question, whatever question, feel free to actually ask those questions on Slack, and I'll be more than happy to answer them.
Yeah, awesome. Thank you so much, Rajesh. That was great. I have a lot of research to do. I have like 18,000 new tabs open to look at here. It looks like we have a question from Zach. I saw mention of using OPA to enforce rate limits. What would that look like? The way OPA is distributed, I think those would be per resource instead of across a cluster of resources, question mark. Maybe using the aggregates built-in policy function. So could you expand on that?
Yes, so you would actually, again, it's a fine-grained control versus a coarse-grained control that comes with RBAC from Kubernetes. So if I want to have a very fine-grained control on a particular resource or a particular pod, you can enforce that, or at least validate that in your validating admission controllers. And if you're writing a mutating admission controller, then you can actually mutate that particular rate limit, and then you can apply that to your to your deployment file. So OPA can be used for enforcing rate limits or any kind of fine grain control on your on deployments.
Awesome. And then it looks like Jared is asking a little bit more about any idea how much the CSI spec is possible for enforcing via OPA and related utilities. I know there's also Kubebench out there, I think, that does a scan and tries to match. What do you feel about OPA?
Yeah, so I think what we do, and I'll probably answer it slightly differently, this one. What we do as part of the Prisma Cloud is actually, we do a lot of CIS benchmarking. So we actually, there's a whole compliance tab within ours, which tells you whether your clusters or your workloads are compliant to a particular benchmark, whether it could be Docker benchmark or CIS benchmark or Kubernetes benchmark. And these benchmarks are pretty exhaustive. There are new things that get added. There could be certain things that actually could be resolved if you have certain OPA policies. So if there are OPA policies that satisfy certain benchmarks, then Prisma, for example, in this case, we will actually bring it up here and show whether you are in compliance or out of compliance. Now you could do the same thing, right? I mean, if you are actually writing your own benchmark tools or own way to actually look at audit compliance, you might look at that particular spec and say, okay, what kind of I mean, we can provide you some data what maps to this a benchmark, and what policy actually OPA can satisfy which benchmark, and maybe you can reach out to us. But I think this is what we normally do actually. I know it's probably not a straight answer, but benchmarks are huge, and I cannot specifically look at one particular benchmark and tell you this is something that's satisfied by OPA.
For sure. Thank you for the thorough response. And that does look like a really nice UX, actually. That would solve a lot of issues I think a lot of people are having in the security realm, especially my company, as we're starting to think about this and reporting upstream, et cetera. So, wow, I don't see any more questions, actually, which is, I think, surprising. Some people are probably just learning about this for the first time and kind of flabbergasted at all they can do. So, no big deal though. The video will be up at the same link you're watching this shortly after, and Rajesh and Scott are both in the Slack channel now as well. So feel free to highlight them and notice them, and I'm sure they'll respond eventually. We'll be in constant contact with them as well. I think there's plenty of other topics that they're interested in talking about, and we'd love to have them back. So if you could, Rajesh, if you go back to the slide on the backpack instructions, I just want to make sure that people caught that really quick. And I'll have Rajesh as well post links to all of the community links and the cloud security boot camp as well. That's really cool to see that they're doing that. So I want to thank Rajesh and Scott for participating. They have now made Palo Alto sponsors of Orchestructure, which is awesome. I want to thank the over 50 unique viewers we had this evening. Thank you so much for tuning in. Us seeing that really drives us to keep doing this in the virtual format. We are continuing to monitor things and see when might be safe. We're dying to see everyone and eat pizza together. And I'm hoping that comes soon. I think June will probably stay virtual. So keep your eyes peeled for the next meetup, next event. And hopefully you're enjoying the format. And I guess with that, thank you. And until next month, take care.
Thank you.